Hey everybody, this is Larry. This is Miko with Q4 of the weekly contest 422 count number balanced permutations. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. So this one, there are two components. One is kind of breaking the problem down a little bit, and it just becomes dynamic programming. And then the second part is the combinatorial part, which is also a little bit tricky, and you have to know quite a little bit of math, both on the number theory and the combinatorial part. Not that much, but still, it's a lot of things to put together. There are a lot of components to put together, and that's all you have to do for this one. I think the dynamic programming one is actually the most straightforward. There are a couple of ways you can think about this one, right? Which is that the odd-even thing, right? The odd index and the even index thing. I think the way that I thought about it is that it's a variation on the tick-no-tick, right? And it's not a tick-no-tick. Then now you just think about, okay, for each digit, for each number, or for each digit, is it going to be on the left side or on the right side, right? That's basically really the idea behind this. So that's the basic idea for the dynamic programming, is that, okay, if a number or if a digit is on the left side or the odd side, say, odd side, then what happens, and if it's on the even side, what happens, right? Pretty straightforward stuff. Well, okay, maybe not, I know, but at least, like, you know, for the hard problem, that is how you would get started, and that's basically the way that I started. I don't have that code on me. I actually have it somewhere on the live version, but I actually modified this a little bit. The first question you may ask is that, well, doesn't the order matter? And the reason why you want to impose an ordering to it, and maybe there are different ways of solving this, just to be clear. Like a lot of these counting permutation problems, sometimes or very often even really, there are a lot of different ways to think about it and attack this problem. I'm just showing you my way, because they're just, mathematically, a lot of different ways are equivalent, and a lot of people do a lot of smart things, and I'm like, oh, that's not the way I did it, but so I'm only showing you my way. And because, and for this problem, you have these things about permutations, right? And counting them. And so, so the first thing that I do for these problems with try to count the number of things and then permutate them is just, well, let's impose an order so that we can just count the number of times that happens, right? So, for example, let's ignore the other constraints about it being balanced or something, right? So instead of just like, and you can actually do this, and maybe that's fine, but I didn't do it this way, which is that, instead of checking whether 1, 2, 3 works, and then 1, 3, 2 works, and then 2, 3, 1 works, what I did is that I always structure it from left to right. Impose an ordering, right? And what I mean by that, from left to right, is just really from 0 to 9, right? So I give an ordering, so I always do 0 first, I always do 1 second, 2 third, and so forth, right? And then once I impose that ordering, then now let's say I have just looking at one side, I still say odd. I mean, I say left and right for odd and even, but it's the same idea. Which is that then now, let's say you have something like this. You have 1, 1, 6, 8, 9, and keeping in mind that because we go left to right, meaning from smaller digit to larger digit, this is always going to be sorted, right? And because this is always sorted, there's always going to be one way. So then now it becomes, in theory anyway, that's my logic, is that now we can just count all the permutations of this, right? And of course, in this case, I'm not going to go over the mathematics of this part, honestly, that much, just because there's a lot to go over, and I think this part is the easiest to self-learn, because this is probably what people teach in, like, I don't know, at worst high school or something like this in math, like in terms of combinatorial, and figure out how the number of unique permutations, right, or distinct permutation, I think is what they call it. Sorry. And what I mean by that is that 1, 1, 6, 8, 9, it's going to be, like another permutation is 1, 1, 8, 9, but you cannot swap the two ones because they are the same, right? And the way that this is just, it's going to be For this particular number, it's going to be 5 factorial over 2 factorial times 1 factorial times 1 factorial times 1 factorial. And the formula really, and I'm not going to prove this and derive this. You can probably Google some of this because, like I said, this is very basic stuff, so I'm not going to focus on it. But basically, given that you have, let's say you have n elements, right? N elements, and you have, say, I don't know, d distinct objects, and or d distinct types of objects, each not differential, or like each not differentiable, or like each object of the same type is the same, right? Then and then now, so and we have say I don't know, v sub 0 of object 1 or object 0, keep it consistent, Larry. And you know, v sub of object 2, right, dot dot dot, right? Then now in here, the number of distinct permutations is going to be n factorial over v sub 0 factorial times v sub 1 factorial times v sub 2 factorial, dot dot dot, right? So this is just, you know, like I said, I'm not explaining this part that much because this is math that, like, this is basic combinatorics, and you know, like a whole lesson could be spent on this, so I'm not going to focus on this part, right? So okay. So yeah, so that's the number of distinct permutation, right, for a given number. So okay, so then now, how do we figure this out, right? Well, now I think we can talk about, or now we can look at the code. Okay, so I did a couple of things here. I just want to, you know, focus on that part. But yeah, first we do the mod. We have an array of all the numbers. I just kind of converted to a number, digit by digit. I don't know. I don't think I used this other than like right here. So okay, fine. But yeah, n is the number of elements in the array. I also don't use n actually. Well, okay, I use n to check whether we have number of odd digits or even digits, right? So here I have the frequency table. So this is a, you know, f sub I is equal to the number of times the digit I appears in num. Right, so that's just the frequency table, pretty straightforward. This is the factorial mod things. I'm not going to go over this too much either. Fact sub I is just you go to I factorial. That's basically you know, modded, right? And I fact is you go to 1 over I factorial modded, and there's a lot of math about modular congruences. I think that's how you would I think that's yeah, and division, right? So another thing that you may consider looking at is just modular arithmetic division, right? I'm not going to go over why this works, even though it is actually very easy in Python. You could see you can see the code, but suffice to say that you know, under mod you can't just divide a number, right? So we have this formula here, right? So you know, you can't just say let's say mod is equal to 10, right? You can't, and if n is equal to 10 factorial. Well, if the top is equal to 10 factorial, bottom is equal to, I don't know, 5 factorial, right? Well, 10 factorial is, I don't know what it is, but 10 is in the number, so that mod 10 is going to be equal to 0, right? And here, 5 factorial is, there's a 5 times 4. 5 times 4 is already 20, so that means that mod 10 is also going to be equal to 0, right? So if you just look at 10 factorial mod 10, over 5 factorial mod 10, this is going to give you a bad time. So what happens is that there's this branch of math, and if you Google for modular congruences or modular arithmetic division, it will show you how figure it out with inverse modular functions. The actual, like, there are ways to do it with basically the extended ORLIT function and stuff like this. I'm not going to get into any of that because, again, this is... So there are two lessons if you haven't done it yet. One is just, this formula for combinatorics. And then the second is all this stuff with modular math. As I said, this stuff, I don't know. Like, if you don't know it, if you don't know it, then, like, you just have to know it, right? Like, and I mean that in the way that there's really... you're not going to derive this part during the contest. Like, this part, maybe you can come up with during the contest if you're a little bit rusty and you could kind of, like, think it through. But this part also, honestly, like, you're probably not coming up with this during the contest, so you just have to learn it if you want to be good enough to solve this problem. It is what it is. Also, just to, maybe this is a good time to add that I probably do not think you will see this on an interview. Maybe I'm wrong. Maybe you're doing an Indian or an interview in India where they do ridiculous problems. But outside that, this is way beyond anything on interviews. So yeah. So that being said, then yeah. I'm going to skip this for now. We'll go back. Let's go over the dynamic programming, right? So then now, keeping in mind that I have a frequency table. So then now, index is actually the current digit that we are considering, right? And f of index is the count of that digit. And then now for this function, we go, okay, well, we have index. We already talked about what the index is. We have delta count. And what this stores is the number, the number of digits on the left minus the number of digits on the right? And you can maybe you could say that left digit is odd, right digit is even, right? Because I guess the first digit is always odd, is how they describe it, even though I think it's underspecified, as I said, but okay, right? So why is delta count enough? Delta count is enough because it also allows us to, one is that it allows us to compress state, but also we need to consider delta count because in an odd even thing, the additional constraint is that, well, there are two cases, right? If the number of digits is even, then you have to have the same number of digits, right? I mean, I think that's understandable. If the total number of digits is odd, then the number of odd digits is just one more than the number of even digits, right? I mean, I think also you could figure that out. And so this is something that we have to check because at the end, these are things that we care about. And what can delta count be, right? Delta count can range from negative 80 to positive 80, right? Because we only have 80 digits. And of course, you can actually bound this a little bit more just because, for example, if you had negative 70, you need 70 to get back to 0, so that's already impossible. So you could actually, like, do more if statements, but in general, yeah, so this has a 161 range or whatever, so that's fine, right? Delta sum is the same idea, but it's the number, the sum of the digits on the left minus the sum of the digits on the right? Or again, you could say that left digits are odd, right digits are even, right? So that's basically it. And from that, what is the range, right? Well, delta sum can go from, well, there are only 80 digits, so on the left side, it could be, let's say they're all 9s, then it could be negative 720 to 720. So this is only about like 1500, I round up, but 1500 range, right? And since index can go from 0 to 9, what are the number of possible inputs is, roughly speaking, 10 times 161 times 400, which is roughly, what is that? Like roughly, well, 2.4 million apparently. But keeping in mind that a lot of these are not possible, right? I mean, maybe the negative 80 is always possible, but a lot of these sums, maybe they're all actually possible as well. I don't know. It depends on the input. But yeah. And each input can do a lot, and there's a for loop in there, so each input can take some time. a bit of time, but many of the states are not possible, right? Keeping it, and what I mean by that is, for example, if index is 0, well, your delta count is not going to go up because you only add and subtracting 0. So anyway, it's a little bit hand wavy, but there are a lot of impossible states. But this is also why this is one example that top down is better than bottoms up, because a lot of the states are not possible. If you try to do this with bottoms up, you're doing a lot of work over states that can never be reached, and that is just not as good, I think. But yeah, but with that said, let's go over the recurrence, right? These are kind of the things that I was thinking about during the contest. But yeah, so this is the base case. If index is equal to length of f, which is always going to be 10 because we always multiply by 10. I don't know why I wrote it this way. So you have two cases, right? Well, if delta sum is not equal to 0, then we return 0 because it's just not possible, because you need the sum to be 0. You need the left side to equal to the right side, or the odd digits. The sum of odd digits is equal to the sum of right digits. So if it's not equal to 0, we return 0. Otherwise, if it is odd, this is if it's even, I don't know. If it is even, then delta count can, then they need to have the same number of digits, right? So that means that you have to have the same number of digits on the left side and the same number of digits on the right side, or odd even. That makes sense, right? Because if it's not equal to 0, we return 0. Otherwise, then we can return 1. That means that if delta count is equal to 0, we return 1. Otherwise, if it is odd, if n is odd, then now delta count has to be exactly 1, because the left side or the odd digits have to be 1 more than the right side. So that's basically it. I think if you're consistent, it actually doesn't matter, but in any case, like if you could probably do -1 and it'll probably give the same, but actually I don't know if that's true, so I don't know. I think that is true though, because we don't even count the ordering yet, right? So yeah, so you have this return 1, right? Yeah. Yeah, and otherwise you return 0. Same idea, right? And then this is the crux of it. You have total is equal to 0. Fine. And then now for every number in the frequency table, that means that, okay, and I should write it here, right? So on the left side, we have we put I index digit on the left, and then the rest we put on the right, right? Which is what we have on the right, which is f index minus I, right? Pretty straightforward as well, I think. And then we just count what happens. And this is the recursion, right? We go to the next digit. Delta count is equal to left minus right, because that's just the, we have now left minus right, so that's the contribution to the delta on this part. Delta sum is the same, except for it's left minus right, times index, keeping in mind that all the index is the digit, and we all have it all the same. So if we have more on the left or more on the right, then we just count it by digits this way, and then we times it by this thing, right, which I'll talk about in a second. But this is the key part of the recurrence, and then we just make sure that we mod it, because we don't want to get it, we don't want it to be too big, and then we just return the mod again, because I don't know, you can never mod too much, I feel like. And then we kick off with the digit 0, the delta sum is 0, or delta count is 0, and delta sum is 0, and that's basically it. Okay, so why do we have this numerator and these I factor things, right? Well, so the idea here is that, okay, let's say we have, I don't know, and they may not equal the same, but let's say we have, one candidate answer. Let's say this would return 1, right? Where's the return 1? Let's say we return 1 on something that looks like this, and they probably don't sum to the same, so just forgive me, it's just to kind of demonstrate, right? Well, we have a number like this. Well, we look at every other digit, right? Let's just keep it even for a little bit easier, right? We look at every other digit, right? So then now you have 7, 5, 8, 1, 3, 6. That's terrible. And then 8, 2, 3, 8, 4, 1 on the. So this is what I would call the left odd portion, and then this is the right even portion, right? Okay, this is a terrible example because we don't have enough duplicates, but let's say I'm going to just change this to 8, 8, right? Whatever. So we have 4 8s, right? So then now, that means that, well, when you combine them, what is this? This is when this number, and let me change this real quick. Oh, I think I messed up. Okay, fine. So it actually is this one and this one. But in any case, so let's say, and this is when you take it out, right? So we have this is the left side, this is the right side, and you combine them to get this number, right? Well, how many ways are there to permutate all these numbers here? And I actually messed this up on the example because it should be sorted, because I think the way that we constructed it is sorted. So maybe okay, let me retry it real quick. So maybe you have like, okay, 0 0 1 1 2 2 4, something like this, right? 0 2, I don't know, whatever, right? And let's say they sum to the same, even though it doesn't make sense. And then now, if you want to create one number from this, you would take one from the left, one from the right, 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 one from the left, one from the right. I may be off by one or something, but you get the idea anyway, right? So how many ways are there to permutate this, right? Well, the thing is that the left side permutates by itself, right? And the right side permutates by itself. And what I mean by that is that, like you can basically, shift around all the digits here and shift around all the the digits on the right, but they do not combine, right? Meaning that you cannot change, like this 5 will never be on the left side for this particular answer. So you cannot swap the left and the odd and the even indexes, but all the left are within itself, right? And as we said, well, so then how many ways are there to permutate this, right? So the way to permutate this will actually be just, well, the number of ways to permutate is just the number of ways to permutate left multiply by the number of ways to permutate right? I mean, it's kind of hard to see because they're interleaving, right? But another way to think about it is just, okay, let's say we have the left digits as this and the right digits as this, and that's it. And then now you could permutate anything you want on the left and permutate anything on the right. Then now they're independent of each other. So it's just the number of ways to do the left times the number of things times the number of ways to the right, right? And the number of ways to the left is going to be equal to, as we already did it, it's going to be n factorial over all the whatever factorial, right? Like v sub 0 factorial dot dot dot. And in this case, this is how many numbers is it? 2, 4, 8, 9. Yeah, this is going to be 9 factorial over 2 factorial, 2 factorial, 3 factorial, 2 factorial, right? And then on the right side, this is also going to be 9 factorial over 1 factorial, 2 factorial, 2 factorial, 1 factorial, 3 factorial, right? And this is basically the idea. So then now, for each number that it is a right answer for, instead of returning 1, we would return this, right? We will return this times this is the number of ways to have this one answer, right? Yeah, right? So then now, the tricky part though, of course, is that, well, you can't really just blindly multiply by a number. Why? Because, let's say you have something like, I don't know. This is kind of tricky to do. Like something like this, maybe. Yeah, I don't know. But basically, it's hard to come up with a case off my head, honestly, such that the math is right. But pretend you have something like this, right? And maybe instead of doing every other digit, we'll just do the left side and the right side. Something like this. And of course, I forget that one will be in the front. But say you have something like this. this number will actually be different from if, like, you know, maybe if you have a 2 here and a 1 here. I don't know, right? But you can see that, okay, so this isn't actually a possible answer per se, but in a similar way though, you can see that in here, the left side is going to be 4 factorial over 1 factorial times 3 factorial. Same thing for the right side. But if you have a possible answer that's actually like like this, then on the so this is this times 4 factorial over 1 factorial times 3 factorial, and then for this one you would actually get 4 factorial over 4 factorial. There's only one unique way times 4 factorial over 1 factorial times 2 factorial times 3 factorial. Oh, no, that's it, right? 1 factorial, right? So you cannot. So that means that this multiplier, this factor is not the same for each possible end result, right? So if you have an end result that is different, it will give you a different response, right? So that's why. And this is actually the last hard part that took me a little bit of time to figure out. And so then I was able to visualize this after a little bit. And I was trying to figure out, well, the thing is that I think the way that I thought about this problem is just trying to figure out how to it's just to figure out how to get the denominator, right? I think the numerator is actually, like, if you look at these things, the numerator is actually straightforward, right? It's always going to be 4 factorial, or if there's an odd number of digits, so let's say there's 7 digits, then it's going to be 4 factorial times 3 factorial, right? So then now the question is, how do we get the denominator? And the denominator, and also just to be clear, this is what this part is that we kind of jumped over before. If it is even, we just have n over. Oh, sorry, I didn't say n, but n over 2 factorial times n to the n over 2 factorial. If it's odd, then we round one of them up, and then, you know, same idea, you get it, right? But then the even is that, how do we figure out how to do all the unique values together? Well, this is why, if you look at the live portion of me solving it, I actually rewrote parts of this to kind of, so that we get the or at the same time, right? As luck as we had it, I is the number of things on the left, and well, f minus I is the number of things on the right. And so on the numerator, we just keep track of this, so we times it by the numerator, and then on the denominator, we factor this in by having it here. And what this does is that basically it takes the count, and then we divide it by the number of unique things that is on the left and the right. And this factor basically is saying, on this part, we want to add the contribution to, you know, so let's say, I don't know. So in this case, we have 6 2's, right? So if we have 6 2's, if we put 3 2's on the left side, we also put 3 2's on the right side. So then now we just take this out, and then we have 3 factorial over 3 factorial, and 1 over this, right? And this is why this is an inverse factorial, which is how we have it. Or modular inverse factorial, or something like this, right? So this is basically what we were adding in as we do this count as part of the contribution. And that's pretty much it. It's very hard, honestly. I feel like I don't know how many people end up getting it. It seems like 365 people. The contest just finished. But yeah, so I'm gonna go over. But that's it. I'm gonna show the code all in entirety once again, and kind of briefly go over it very quickly. So yeah, yeah. So you have mod array, n, frequency table, factorial, inverse factorial, numerator, denominator, and then just dynamic programming over the frequency table. And that's pretty much it. Yeah, I'm gonna leave it here. Well, actually, let me just leave it to the top of this code, and then the bottom of this code. I know I didn't go over that much on the dynamic programming portion, but I feel like if you don't understand the dynamic programming portion, you probably have to practice a little bit more on that part. It is a prerequisite for this. There are hard enough parts to this one already, so that's why I'm kind of skipping a little bit on explanation. I mean, to be frank, the explanation part is already half an hour. So, yeah. So that's pretty much how I did it. Let me know what you think. Thanks for watching. Oh yeah, what's the complexity, right? Well, actually, we already talked about this. We kind of analyzed this a little bit. Like I said, there are a lot of it looks really high in the worst case, but a lot of the states are not possible, which is why it is fast enough. And yeah, that's all I have for this one. Thanks for watching, and you could watch me solve it live in the contest now. That is 2 cells. Okay, whatever, YOLO. Okay. 2 people's got this already. Mod. Alright. Is this the same as the first one? I guess so. I mean, same idea. Obviously, it's not the same. Okay. 80 digits. 2 people got it already. Distinct permutation is not a permutation, but okay. What is balancing? Oh. 80 things, so we go left, right. Isn't it just that? I don't get it. Oh, it's permutation, so maybe I can do quite just this. Okay, I have to think about it a little bit. Because it's number permutation. No, it's still gonna be variation of this. And then you just have to count it in a better way. Okay, I mean, I think that's right. That's reasonable. We do. Right, and then we want them to be the same, but also total sum. Oops. And a delta count or something like that, if I could type correctly. And then is 80 factorial a big number? I guess so. So if n mod 2 is 0, 0, then delta count has to be negative. Okay, and then here, if n mod 2 is 0, 0, then delta count and if delta count is not 0, then we just return 0. Otherwise, if delta sum is not equal to 0, we could also return 0, but I think we can just do that beyond that. Right? Otherwise, okay. So we have 700, so it's about 1,000 in each direction. I think we should be good. Delta count is fine too, right? So then else, if it is odd, delta count has to be 1. Is it 1 or negative 1? Or does it matter? The first 1, 2, 1. Okay, 1, 2, 1. Okay. Now this sum has to be the same. 1, 2, 1 is not the same as. No, there's only one way, so okay. I think we're good. Oh. I guess you could simplify this, but I'm not going to. Okay. So then now, I forgot to sort this. Don't think it matters actually. But and it's not, this is not right, but that's fine. It's not right because, do I have to count the number of weeks? This isn't quite. Is it always permutation? For every possibility. Three factorial over 2 factorial over 1 factorial, right? Yeah, okay, I don't think that matters. Yep, what am I doing? And it is this times, is that true? I have to handle this a little bit better, Larry. Because you're double counting the positives and the negatives and the order of operation. Okay. Yeah, you're double counting even if you didn't do it yet. What you want to write is something like this is wrong. Okay, that's fine. That's fine. You have to skip. That's all. Then now it's easier, maybe. Okay, we'll see. Yep, you're doing two things. Focus on one. That's for the total. I don't think I have to really, it shouldn't matter for this one. One, two. How does that work again? 1, 2. It is f to the power of -1 given over mod, I think. Not f, just some x. And then I don't know why I'm writing this in such a funky way. And then now this is k. right? And then P. Okay, and this is wrong, but how far behind am I? No one has submitted yet, it's probably unlikely. Thank you, Leetcode. Okay, fine. This is not right because of it double counting, which should not appear here really. I think this is just lucky actually, but why is this wrong actually? Why is this only 1 and not 2? It should put 1, 3, 2. Okay, that's 1. And then next it puts the 1. Oh no, because then I don't count the variations of it because I do it in order. But then I do part of it in order, but the other part's not. That's why I have to clean it up. Okay. Just want to see real quick. 6, 6, 120. Okay, that's good. Is that good though? Because this should be over 2. This should not be 6. It should be 2 factorial. Am I doing the? I'm always forget how to do the inverse thing. And then now it's not responding, which is actually, yeah, that's not great actually. K is 1, K times J, V is 2. Oh, what? This is a 1. Okay, that's why. That's not right either, is it? This is definitely not, should be returning a 3. So 2 factorial. One over 2. P is 6. Oh, it's just not modding. Okay. Okay, yeah, okay, that's fine. All right. I just forget my maths. I'm doing very silly things, honestly, just wasting time because I'm not as practiced as I used to be. But okay, now we have to change this again. Okay. So this is the number of possibility for each unique way. So then, okay, so then now we have this is a silly way of writing it, maybe. Okay, so then now this is length of f. This is fine, and then now we write a for loop instead, right? So for I in range of in range of f sub index. If f sub index is 0, you want to put from 0 on put one side and 0 on the other. Yeah, okay, I think that's fine. So then now we add it to index plus 1, but then we have delta count. Left is equal to I, right is equal to f index, right, minus I. So then now delta count plus left minus right, delta sum plus left minus right times index. Mathematic. We in f dot values key for we in f 110. That's not quite right. We have to time this by p, the number of things every time. That's not right either, is it? Oh wait. So okay, so that means that for every possible, because the ordering matters. I'm doing the math wrong. That's what I was trying to go for, but okay. So given one possibility, there are, in this particular instance, is it 3 factorial? I don't think so. I think I'm doing this problem wrong. I thought it would be 3 factorial, but it's not true because it's the odd and the even things. So how do I do the math out on that one? What would this be right on? So 1, 2. So we have to do the number of things on the odd side minus. We have to keep track of all that. Okay, well, okay, I think I maybe get it, but so this is the total. Do we even care about the total? No, because it is an odd even thing, so this actually doesn't even come up, but it's okay. Okay. I think it's 1. Yeah, it doesn't matter. Whatever. I don't know. Then. I think you could probably be smarter than that, but that's fine. So then now, what is the numerator? Numerator is going to be multiplied by. Okay, so then if whatever. If n equals to 0, 0, then it is going to be it's going to be equal to n over 2 factorial. I forget to mod this, actually. That's pretty bad. That could have been a timeout. To the factorial of this times the factorial of this, right? Else it is going to be just this, but round up, right? So you have, say you have 5 is 3, 2, right? Okay. So then it's this times this, but we have to figure out the numerator, which is fine. Right, 220 is very wrong. But then now so the left side is I, so we times this by I times this by left is the left number and right is the right number. Okay, thanks, Past Larry. Okay, so we're Gucci, Arito. I think that's just 1. Oh, 0. Oh yeah, of course. Actually, that is actually the right answer, but 1. Okay, am I right? I don't know. Is it time to YOLO? Let's at least try a big number, Larry. Okay, fine. I don't know if that's quite the right way to. That was very fast, actually. How about I don't know. It's okay. We have time, right? I mean, that seems fast enough. Is it right? I don't know, but we don't even know what. I mean, okay, so we just have a random 80-digit number, maybe. That's not. These numbers are not all even the same length. Am I just like being dumb? 87, 83. Why? Oh, maybe because it's inclusive. Okay. Okay, I'm just being dumb. But even for the bigger numbers, that looks good. I don't like the number of zeros though. Why would it be 0? It just seems unlikely. But okay, maybe not. Alright, YOLO submit. Wouldn't be surprised if it's wrong, but hopefully I get something that tells me, okay, so I got it right. It's okay. Nobody submitted though, so I have no idea how this finished. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this contest, the problem, the explanation, everything in between. Stay good, stay healthy, do good mental health. I'll see y'all later and take care. Bye bye.